let's talk about the equilibrium a body can have. A body can have translational equilibrium and rotational equilibrium, either or both. In translational equilibrium, summation of forces on that body is equal to 0 as the forces are equal to 0, or summation of forces are equal to 0. That means acceleration is equal to 0. So in translational equilibrium, we can have static and dynamic equilibrium. Static equilibrium is when the body is at rest, and dynamic equilibrium is when the body is in motion, and that too when velocity is constant. Now, this translational equilibrium can be of three types. One is stable equilibrium, unstable equilibrium, and neutral equilibrium. In stable equilibrium, we say that when a body is disturbed from its equilibrium position, it regains its equilibrium position, like a book lying on its face. When we slightly disturb a book, if it is released, it comes to its equilibrium position. In that case, when it is slightly disturbed, the center of mass goes higher. When a body is in unstable equilibrium, example of unstable equilibrium is a book lying on its edge. When it is slightly disturbed, it gets disturbed a lot, and it tends to come into the position of stable equilibrium. That means when a book is lying on its edge, the center of mass is here. When it is slightly disturbed, the center of mass comes down. And another is neutral equilibrium. The neutral equilibrium is when a body is in equilibrium and it is disturbed, it continues to be in that state, like a ball rolling on a surface. Now, we also know that the force is equal to minus du divided by dr. As in translational equilibrium, the summation of forces is equal to 0, which is possible only when the potential energy is constant. Potential energy is constant meaning as if the potential energy is maximum or minimum. So in equilibrium, in translational equilibrium, the potential energy of that body tends to be maximum or minimum, as if the rate of change of that potential energy with respect to distance is equal to force. As the force is equal to 0, or summation of forces is equal to 0, that means the potential energy is maximum or minimum. Now let us talk about rotational equilibrium. A rigid body can have rotational equilibrium as well as translational equilibrium, either of the two or the both. A body is said to be in rotational equilibrium when the body is at rest, or when the body rotates with uniform angular velocity. Uniform angular velocity or constant angular velocity means the angular acceleration of that body is equal to 0. If angular acceleration of that body is equal to 0, that means the summation of the torques acting on that body is equal to 0. So for rotational equilibrium, the condition is the summation of torques is equal to 0. That means alpha is equal to 0. So when a body is at rest, or when a body is moving with constant angular velocity, we say that the body is in rotational equilibrium. Now often a question is asked about what is a partial equilibrium. A body is said to be having a partial equilibrium if it has got translational equilibrium, not the rotational equilibrium, or rotational equilibrium, not the translational equilibrium. When either of the equilibrium is present in a body is said to be having a partial equilibrium. We can cite an example. Let us take a rod resting on this place. Let F force be applied here and F force be applied here. It is the force arm that is A, and it is A. Now, as the forces are in the same direction, that means summation of forces is not equal to 0. As summation of force is not equal to 0, this body is not in translational equilibrium. Now, when we go for the torques, F cross A, that is clockwise torques are taken to be negative. Here the torque is F cross A, that means it is anti-clockwise torque, that means it is taken to be positive, FA and minus FA. This is clockwise torque and this is anti-clockwise torque, that sum of the torques is equal to 0. As the sum of torques is equal to 0, this body is not going to rotate. As this body is not going to rotate, that means it is in rotational equilibrium. So it is not in translational equilibrium, it is in rotational equilibrium. That means the body is having a partial equilibrium. Let us take another example. Let this be A and force F be upwards. Let this be a force arm and force be downwards. In this case, as the force is upwards and this force is downwards, these are equal and opposite forces. As these are equal and opposite forces, these cancel. That means the summation of F is equal to 0. The summation of F is equal to, as the summation of F is equal to 0, this body is in translational equilibrium. Now let us go for the torques. So F cross A, that will be anti-clockwise torque. F cross A, that will again be anti-clockwise torque. This is positive torque, this is positive torque. That means this body is going to rotate in anti-clockwise direction. As this body is going to rotate in anti-clockwise direction, or we can say that the summation of torques is not equal to 0. The body is not in rotational equilibrium. As the rotational equilibrium is not present, but translational equilibrium is present, that means this condition is partial equilibrium. In this case, rotational equilibrium is present, translational equilibrium is not present. That means this is a case of partial equilibrium. Okay, thank you.